Combination factoring. Pause the video and try the warm-up. On number 1, the greatest common factor is 4. Both terms have at least an x squared, and both terms have at least a y. So I want to divide all the terms by whatever the greatest common factor is. Always write your GCF out in the front. A lot of people forget to write out in the front. And then do the division to get your leftovers in the parentheses in the back. So 12 divided by 4 is 3. X squared divided by itself cancels out. And then remember, there's an invisible 1 right here as the exponent on the y. So when you're dividing like bases, subtract the exponents. So 3 minus 1 would be a 2 on the y. In the back, 16 divided by 4 is 4. X to the third divided by x squared is x to the invisible 1, but I'll just write x. And then y divided by itself cancels out to 1. If you multiply this back out, you should get what you started with. On number 2, always check to see if there's a GCF first. So there's no GCF other than 1. So I'm looking to see how many terms it is. So it's 2 terms, so it's a binomial as opposed to a trinomial. It's subtraction, and both terms are perfect squares. So this is the difference of 2 perfect squares factoring that we did yesterday. So I'm going to get my 2 sets of parentheses. Square root of x squared is x. So x squared basically just gets split into x times x. Square root of 64 is 8. Make one positive, make one negative. And there you go. For number 3, is there a GCF other than 1? No. Is it 3 terms or 2 terms? 3, because you have 1, 2, 3. So then you're looking to do basic trinomial factoring. So that's the one where you multiply to the number in the back, and then you add to the number in the middle. And I forgot to mention this in the video the other day when I was doing basic trinomial factoring. If you can just automatically brainstorm the 2 numbers that multiply to 20 and add to 9, do that, jump to that. You don't have to write down all the steps like I've been writing them down. I'm just pretending I'm someone who's not great with my number sense and listing out my options until I get to the right answer. But if you just know the 2 numbers that work, go ahead and just jump to your answer. So again, pretending like I don't know my numbers super well, I just start with 1. So 20 divided by 1 is 20. 1 plus 20 is 21. That doesn't work, so I'll try 2. 20 divided by 2 is 10. 2 plus 10 is 12. That doesn't work, I'll try 3. 20 divided by 3 is a decimal. I won't even bother writing it down. Try 4. 20 divided by 4 is 5. 4 plus 5 is 9. There we go. I found the 2 numbers that multiply to 20 and add to 9. So I come over here and I write my answer. The x squared gets split into x and x, and then I use the 2 numbers that work. So 4 and 5. Number 4, is there a GCF other than 1? No. Is it the difference of 2 perfect squares, or is it a trinomial? Okay, it's a trinomial, that's 3 terms. So I'm looking for 2 numbers that multiply to negative 18. Those same 2 numbers need to add to negative 3. Start with 1, so 18 divided by 1 is 18. Now notice on this one, we're supposed to multiply to a negative number, so one of my numbers has to be negative. I'm also trying to add to a negative number, so I'm going to put the negative sign on my bigger number, because that's the only way I'm going to add up to a negative number. So 1 plus negative 18 is negative 17. That doesn't work, so let me try 2. 18 divided by 2 is 9. Put the negative sign on the bigger number. 2 plus negative 9 is negative 7, so that still doesn't work. Let me try 3. 18 divided by 3 is 6. Put the negative on the bigger number. 3 plus negative 6 is negative 3. There we go. We found the number. So I come over to the side and get ready to write my answer. Remember, the x squared gets split into x and x, and then I use the 2 numbers that we found off to the right. So the 3 and the negative 6. So, new thing for today, combination factoring. No matter what type of factoring you're doing, you should always factor out a GCF if one exists. If you can factor the leftovers, you need to do that in order to factor completely. So nothing really super brand new today. It's just the fact that if you can divide out a GCF first, do that. So for example, on number 5, when you look at that problem, all of the terms have an x, or I should say all of the terms have at least an x. So that's my greatest common factor. So I'm going to divide out an x first, and then here are my leftovers after I divide out the x like that. So the trick, the new thing, look at your leftovers in the parentheses. It's a basic trinomial. So I'm going to have to factor those leftovers in the parentheses in order to factor completely. So I want two numbers that multiply to 5 and add to 6. So 5 divided by 1 is 5. 1 plus 5 is 6. So the very first two numbers I tried worked. So I'm going to drag down the x in front, and then I'm going to factor the trinomial like we've been doing the whole time. So the only new thing with 5 was just the fact that now we have that greatest common factor out in the front, and then the leftovers were the basic trinomials like we did in number 3 and number 4 in the warm-up. Why don't you pause the video and try 6? So on 6, the greatest common factor, let's see if we have one. So all of those coefficients, the 4, the -4, and the -80, all of those numbers are divisible by 4. All of those terms have a b in them, and then all of those terms have at least an x in them. So I want to factor out my GCF of 4bx first. So 4bx out in the front, and then your leftovers in the back. And then when I look at my leftovers in the parentheses, it looks like it's a basic trinomial. So I'm looking for two numbers that multiply to -20, and then those same two numbers should add to -1. Because remember, if you don't see a number, there's a 1 there. Same thing with all those exponents, remember? Like back at the beginning here, all these x's had 1s on them. All those b's had invisible 1s on them. So just keep in mind that if you don't see a number, there's an invisible 1 there. All right, so back to trying to find two numbers that multiply to -20 and add to -1. So 1 times 20, the bigger number needs to be negative because I'm trying to add up to a negative number. So 1 plus -20 is -19. That doesn't work. Let me try 2. 20 divided by 2 is 10. Bigger number has to be negative. 2 plus -10 is -8. That doesn't work. 20 divided by 3 is a decimal. I'm not even going to write it down. 20 divided by 4 is 5. Bigger number is negative. 4 plus -5 is -1. There we go. So make sure you drag down your GCF in the front. That's a really common mistake to forget that GCF. So drag that down. And then we had the 4 and the -5. Go ahead and try 7 and 8. And then we'll try those out. So on 7, you'll notice our first term is negative. So we're going to want to factor out the negative version of the GCF. So all those numbers are divisible by -3. And then there are no variables in all of the terms. So I can only divide out a -3. Then I'm left with m squared plus 10m plus 16. So then looking at your leftovers, you want to notice that you have a basic trinomial. So I'm looking for two numbers that multiply to 16. Those same two numbers need to add to 10. And again, if you already know the two numbers that work right off the top of your head, don't feel like you need to write down all this stuff in this little T-chart off to the side. You could just jump to your answer. I'm just pretending like my number sense isn't so great and going through the options, because that's something that most people struggle with, especially when they're first learning how to factor. So 16 divided by 1 is 16. Everything's positive, so I'll just leave everything positive. That 1 plus 16 is 17, so that doesn't work. Let me try 2. 16 divided by 2 is 8. 2 plus 8 is 10. So there we go. Those are the numbers that work. So drag down your GCF in the front, and then you have a 2 and an 8. On number 8, GCF is 3. So you want to divide out of 3. And then this one's a little different because when you look at your leftovers in the parentheses, it's not a basic trinomial. Instead, there are only two terms, the x squared and the 25. It's subtraction, so it's that new thing from yesterday, the difference of two perfect squares. So remember, difference of two perfect squares is the one where you want to take the square root of the first term and put that in the first slot. So square root of x squared is x. Take the square root of the second term, so the square root of 25 is 5. Put that in the second slot, and then make one positive, make one negative. Finish off the rest of the worksheet, and then check it with the rest of the video. So on number 9, no GCF other than 1. I have 3 terms, so it's a basic trinomial. I want to multiply to negative 18 and add to negative 7. So since I'm multiplying to a negative, one of my numbers has to be negative. Since I'm adding to a negative, the bigger number has to be negative. So 1 plus negative 18 is negative 17. That doesn't work. Let me try 2. 18 divided by 2 is 9. Bigger number has to be negative. 2 plus negative 9 is negative 7, so that does work. So then I have x plus 2 and x minus 9. And remember with factoring, if you multiply out your answer, you should get what you started with if you've done it correctly. Number 2, GCF is 2. So if there's a greatest common factor, you always want to divide that out first. And then looking at my leftovers, it's only 2 terms and it's subtraction. So it's going to be the difference of 2 perfect squares. So I want to do square root of x squared is x. Square root of 36 is 6. Make one positive, make one negative. Number 11, GCF is 3. So I want to divide a 3 out of everything first. And then when I look at my leftovers, it's a basic trinomial. So I want 2 numbers that multiply to negative 16. Those same 2 numbers want to add to 6. I'm multiplying to a negative, so one of my numbers has to be negative. I'm adding to a positive number, so I'm going to make my smaller number negative. So negative 1 plus 16 is 15. That doesn't work. Let me try 2. 16 divided by 2 is 8. Put the negative on my smaller number. Negative 2 plus 8 is 6. That does work. When you're continuing your factoring off to the left, make sure you drag your GCF down in the front. I know I've mentioned that a ton, but I keep mentioning it because it's a really common mistake for that 3 in the front to just magically disappear, and it needs to stay there. For number 12, that is no GCF other than 1. I only see the 2 terms. They're both perfect squares, and they're being subtracted. So this is the difference of 2 perfect squares. Square root of x squared is x. Square root of 144 is 12. Make one positive, make one negative. Just a reminder, if you're using your calculator, when you type in square root 144, you're not doing the negative sign. You're just doing square root of 144. If you try to take the square root of negative 144, you're going to get an error. 13, GCF is 5. All the terms have at least an x, and all the terms have at least a y squared. So 5xy squared needs to be divided out of all of the terms. So in that first term, remember any exponents that you don't see, they're invisible ones there. So all those x's are x to the invisible 1. And when we are dividing like bases, you're subtracting the exponents. So on that first term, 5 divided by 5 cancels out to 1. X to the third divided by x is x squared, because 3 minus 1 is 2. Y squared divided by itself cancels out to 1. Next term over, negative 15 divided by 5 is negative 3. X squared divided by x is x to the invisible 1, because 2 minus 1 is 1. Y squared divided by itself cancels out to 1. In the back, negative 10 divided by 5 is negative 2. X divided by itself cancels out. Y squared divided by itself cancels out. Looking at my leftovers in green, basic trinomial. So I want to multiply to negative 2 and then add to negative 3. So let's see here. I feel like I made a mistake. Negative, negative. So 1 times 2, I need one of those numbers to be negative, and then the bigger number should be negative because I'm trying to add up to a negative. So 1 plus negative 2 is negative 1. That doesn't work. And then there really aren't any other options. So on this particular problem, we cannot factor the leftovers any further. And that's fine. You don't have to be able to factor the leftovers. You just have to check and make sure you can't factor them. On 14, GCF equals 7. So I'm going to divide by 7. And that's it. It's a nice short one. Because when I look at those leftovers, the x minus 2, yes, it's 2 terms. Yes, it's subtraction. But x is not a perfect square, and 2 is not a perfect square. So I can't do difference of 2 perfect squares factoring on the leftovers because I don't have 2 perfect squares. So I just have to stop on number 14. On 15, GCF is 4. So I want to divide everything by 4 to start. And then when I look at my leftovers, that's a basic trinomial. So I'm going to multiply to 8 and add to 9. 8 divided by 1 is 8. 1 plus 8 is 9. So 4 and then x plus 1, x plus 8. On 16, 6, right? 12, 6, and 18 are all divisible by 6. All the terms have at least an x to the third. And then all the terms have at least a y squared. So I want to divide everything by 6x to the third y squared. Always write that GCF out in the front. And then when you're dividing like bases, subtract the exponents. So on those x's, 6 minus 3 is 3. On the y's, 3 minus 2 is 1. So y to the invisible 1. Minus 6 divided by 6 cancels. On the x's, 4 minus 3 is 1. So x to the invisible 1. And then y squared divided by itself cancels out to 1. In the back, 18 divided by 6 is 3. X to the third divided by itself cancels. And y squared divided by itself cancels. Now, when I look at my leftovers in the parentheses, it is a trinomial. It does have 3 terms, but it's not an x squared term in the front. So we can't factor this like we were factoring all those other basic trinomials because I can't split x to the third and the y. I can't split that up. So I'm just going to stop here, again, because that first term wasn't an x squared that could be split up. On number 17, no GCF other than 1. I see 2 terms. I see subtraction. Both terms are perfect squares. So there should be the difference of 2 perfect squares. So the square root of 9 is 3. Square root of x squared is x. And then in the back, square root of 100 is 10. Square root of y squared is y. Make one positive, make one negative. And then that last one, no GCF other than 1. So I want to look and see I have 3 terms. So it's a basic trinomial. I want to multiply to 10 and add to -7. So since I'm trying to add to a negative number, both of my numbers have to be negative, because that's the only way I can multiply to a positive and then add to a negative. So 10 divided by 1 is 10. Make them both negative. -1 plus -10 is -11. That does not work. Let me try 2. 10 divided by 2 is 5. Make them both negative. And there you go. -2 plus -5 is -7. So x minus 2, x minus 5.